centimeters squared is mounted so that I can rotate about a vertical axis which is at right angle to a uniform magnetic field. Okay, so I'll draw this for you. I think so, isn't it? But I'll draw this so you can have a good picture. Just wait for the writing program to open.
Teacher, are you free after this class?
Oh yes, not only am I free,
Do you want to do math?
but I'll be teaching you. Yes.
Yeah. Okay. Yeah.
Well, how did you know you didn't have chemistry? Who emailed you? How does she know? Alright, so what you have here is north. Okay, I really.
Why don't you run
Okay. I'll just write it up here. So you have north, you have south, and you have this vertical plane here, and the field is going this way. Okay, and the area is 25. It'll reboot. I'll write it so you can see when it comes up. The area is 25 centimeters squared, and the magnetic flux density is 750 millitesla. Yeah. So the question is, what is the force? And if you have a current of 800 milliamps and a number of turns is 100. So the formula for force is what? Yeah. Or in this case actually N-bill. But you have 100 turns.
Yes, N-bill. Oh. N-B-L. N-I-L. We don't need to neglect it.
Huh? What's the problem here?
We don't need to neglect it, what the fuck?
Bill is when you have one wire in a magnetic field. A wire, yeah. So you need to multiply by n. So is your answer off by 100?
Because
okay.
The original formula is U.
Yeah, the original for a wire. Okay, now that's the second time the two of you neglected to consider the n. It's just fine. Just don't do that in the exam. This is why we practice, okay? Right, so you're recalculating now. It's 100, 0.75, 0.8. Hang on. The L is... What's the L? Is it?
5? No.
No, 5, yeah.
No, because it is square area, so square, yeah, so 5.
Do you know what? Hang on. I know the formula turning force equals I-ban.
Yeah.
Okay? And we also know that turning force is force by distance.
Yeah.
So you have force by distance equals IB distance by length, if you have it like this. But obviously these are the same because it's a square. Anyways, I can cancel that with that, and the force, oh, I lost my hand, sorry. The force would be IB ln, or as I wrote it, N-bill. Yeah, so you're right. No, I just double checking. It's the 5, because if it's 25, it's 5 by 5.
Yeah.
So that is 0.05. Okay, so what do we get here? Alright, well the next part's actually what I was just doing there. The torque, which is I-ban. Or it's also the force by the distance, which would be 3 by 0.05. 0.15 Newton meters. And then lastly, the magnetic flux linked with each turn of the coil when perpendicular Also just NBA cos theta, isn't that the one? Yeah, this flip. I really hate when the English is not clear. Do they mean the problem is the word width, W-I-T-H. Can I scroll down? I'll explain the problem I have with the last question. It basically says calculate the magnetic flux with each with each term. Now, I don't know the meaning of the word width here. I don't know if what they mean is calculate this considering each term or calculate this for each term. So I don't know if this width means considering or could it mean for. Well, even linked. Linked just means... You see, the problem is, in this context, when you talk about link and linkage, it means total. Linkage means total. Yeah. I don't know if it means really to say determine the total flux considering each term, in that you have to multiply it by n. Now, let me read it once. I'm going to make a decision, and then I'll see in the marking scheme if I would have been right or wrong. Determine the magnetic flux linked with each turn of the coil when perpendicular to the plane of the coil is at an angle 60. I am going to include the n. I'm going to take a chance, and I'm going to think that they mean... Shake your head at me. Did you check the marking scheme? Are you sure they didn't put in n as 100? Are you sure?
No. Trust Stephen.
No, don't trust me, because the problem here is with the English. Do we? What do you think, Sean? Would you count the n or no n here? Would you use this formula? Or would you use this formula?
This formula.
Don't.
The first one? This? Oh, each is no.
Okay. Maybe I'm thinking about the English too much. Everybody's feeling that this is the one to use.
But even though we do n, it's also
each
the same
term.
Yeah, each turn, yeah.
So,
Well, Monica's going to check the answers for us.
But teacher, even though you add the n, is it still the same because it's each term?
No, there's a difference of 100 between the two answers here.
Okay. Yeah.
each term is one term. Equal.
Perhaps. Monica's going to check. They didn't? Good job, guys. You would have gotten the mark here when I didn't. Although I think for the rest of the exam I might be getting the marks when you don't. But at least on this occasion, you got it. Good job. So what is the answer here, Monica? 10 to the minus 4 Webers. Okay. Do we need to do the next one? The transformer question?
Yes.
Lee, do we need to do the next one? Have you even looked at it? What?
Yes.
Really?
Come on, we have to follow step by step. It's like a procedural thing,
Okay.
Alright, fine. I'm a bit surprised, Lee, but okay. Okay.